give it another, well, it's 3, so I'll get this started. Hello, everyone. Welcome to another episode of SecCast Live. So before I get into anything, I just wanted to let you all know that the way we're going to work this is feel free to ask questions via the GoToWebinar. We do have panelists to answer your questions, and if they cannot, I've baked in some time for Q&A, and we'll go over those. We'll answer those questions then. So I'll just get right into it. So we're nVisium. These are the suite of services that we offer. We do web and mobile assessments, code remediation, which means anything we find, we also can fix. Training, we do lots of training. We have remote and on-site options and a whole other set of things that we offer around training. So go ahead and ping us if you'd like that. And then we have services centered around integrating security into your development shop. So if you know anyone that's interested or you're interested, please reach out to us. Maybe we can help. Okay, so going right into it. So this is top 3, the Rails edition, and I just want to really make it clear what that means. So within this format, within this time frame, we picked the 3 both most prevalent and damaging vulnerability categories that we could pull out. There are lots of other things we see in Rails applications that are very prevalent and very damaging, like mainly centered around logic flaws and business logic flaws. But those are just so unique to each and every application, so we wanted to go with something a little bit generic for this format. So, who am I? Why am I talking to you about all this? So I'm the CTO of nVisium, kind of speaker and trainer and all that stuff. But what I really want you to get out of this is that I've reviewed a lot of Ruby and Rails application code, just a plethora, and I've trained hundreds of developers. So, what I talk about here is just what really matters, and it's based off experience. So take that in mind as I go along here. So again, these are these top 3, the ways we show how they manifest, that's based off the results of our assessments. And then the tools that I'll be using. So Firefox, pretty simple. RailsGoat, I'm sure you've heard about it if you're on this episode. TextMate, yeah, get your chuckles out. And then Burp Suite Proxy, which if you're not familiar with a proxy in general or an intercepting proxy, it's software that sits on my local machine, and it's only intended for me and me only to modify my requests. Like, this is not something I'm using to attack somebody else. This is just, bypassing any sandboxing that's been done using JavaScript in my browser. I'll fill in form fields, send it off, intercept it, modify that request any way I want, maybe automate some things, and then forward it onto the web app. That's just for me as the attacker for my requests. And we're going to talk about mass assignment, metaprogramming, injection, and then we've got that QA time. So let's cover mass assignment. We're going to do some code, show the database, and we're going to attack. So the first thing I want to basically ask, which is sort of a rhetorical question given this format, is mass assignment a vulnerability? And the answer to that is it's absolutely not a vulnerability. It's not. It's a feature. It's a function. It exists in other frameworks. It might be called something different, but it's okay. It's how we use it that introduces security issues. So we're going to talk about that for Rails 2, 3, and 4, because I know some folks think Rails 4 it's bulletproof. They don't have to worry about it, and that's absolutely false. So we'll cover the 2, 3 first, and then jump into 4. So this is what you probably have seen before. It's a user controller, create action, and we want to instantiate a user model with user.new and pass it in params. And the params, it says user, and that's really just a set of parameters from email to first name, last name, and anything else that you were intending to go in there. And you'll see the model at the bottom. We've got some accessible attributes defined. here's our database. 5 users, totally normal, totally typical, all at metacorp.com addresses. That's going to come into play. So what are we hoping happens as a developer? Well, we want to create a form, and that form is going to have some attributes that we'd like to exist when we instantiate a user. So I want to know your email address, your first name, last name, and all that fun stuff, your password. So I'm going to create a form with some code, and it generates a nice sign-up form. Cool. These are all the details that I'm expecting to get. And when I hit submit, an HTTP request gets generated. And this is what a raw HTTP request looks like. This is a post request to the /users path, and it's got the parameters there at the bottom. They're URL encoded, so they look a little funky. So there's a cleaned up version. You can see we've got the user email, first name, last name, password parameters, as usual. And we're going to go with goodguy@sync.com for that email address when we create this user. So what it looks like under the hood is pretty much what you'd expect. User.create, pass in email, first name, last name attributes, and then under the hood with the SQL statement that actually executes, you see the insert into users admin auth token, all that fun stuff. And the result is a Ruby model object, which is a database object. And so you can see that database object. We've got 6th user now, goodguy@sync.com. Cool. So given what you've seen so far, you know that the admin adder is accessible. So what we're going to do as an attacker is try and go after that, right? So this is what you've probably seen before. Put in some details. So we filled in this form. We've got badguy@hacker.com, and the details you'd expect. This is my intercepting proxy for those of you that aren't familiar with it. When I hit submit, request is going to come in here. I'm going to modify it. So request comes in. I want to go to the cleaned up version, make it a little easier on myself. And I'll add a parameter because the form didn't make this parameter. Why would it, right? And I'll just say true. I could do 1, but I'll just do true. And so the idea is when this record gets created, then I should be able to go in there and take a look at the database and see that this this user that was created has an attribute. So there's the badguy@hacker.com has an attribute of true in the admin section. And you can see, sure enough, I'm an admin. So, and that's, I think, for some people, that's, they've seen that. Okay, cool. But I still need to cover it. So going back to Rails 2 and 3, there are 2 main ways we see people shoot themselves in the foot. And that's, permitting certain attributes that they wouldn't want in there, or, aren't aware that are actually accessible, which happens a lot. And then the other way is just disabling it. And I think that, so Rails 4 was built a different way, right? We've got strong parameters and it all works differently. And I think maybe the issue for a lot of folks that we've seen and why they do this is they want flexibility. They don't like the model telling them they can't have certain attributes sent in at instantiation time. But I would say don't do this. Don't do this. It's a little bit of extra work. It's worth it because every single app that disables this has serious issues. And I can say that unequivocally, so don't do this. Rails 4, on the other hand. So a little bit different. The controller has a way that we're seeing people use now to bypass the individual parameters, the restriction where you have to give specific parameters that can be allowed when you instantiate a model. However, when you use the .permit bang, you don't need to specify that. You can just say anything can come in and instantiate a model. So we're seeing people do this, which is causing serious problems for them. So I'd say don't do this. It's not a great idea. There was a reason that protection was built in. I'm not a fan from a security perspective of being in the controller and being limited to the controller with the params object. But here we are, so don't bypass those little bit of security that we still have left there. Rails 4, one other thing to keep in mind is that anywhere a model is instantiated, and I said it before, but I really want to reiterate this, anywhere a model is instantiated outside of a controller or within a controller, but not using the params object. So let's say you use CSV load or JSON load and you do something funky and it's not a params object and you instantiate that model, your protection's gone. So it's a very, very specific instance in which Rails actually protects you. So that's how Rails 4 can be problematic. The prevention for all of this is just knowing what I just showed you. I mean, these are very basic rules to go by. We could get super fancy and super in depth, but that would just be for show. I mean, if you know these things, you should be fine. But you should also be auditing so if you're using Rails 2 or 3, you should be auditing your application's models to see what attributes are allowed. Because oftentimes we go in, we say, hey, you had this and now we're an admin of your site. Or we were able to do X with this model. And people kind of slap their forehead and they're like, that really shouldn't have been allowed. And somebody had committed that code and allowed some attribute to be in there. So you should be auditing. And then Brakeman itself will flag on certain types of attributes. So if they have something underscore ID and it's in the adder accessible area or in the clause, it will flag for that, but still not a silver bullet. And then when it comes to Rails 4, it will flag for a dot permit bang. And I'm not sure if it does it though for if you're instantiating a model outside of the controller with something or with something other than params. I actually don't know that. So audit yourself. So we're going to move on to metaprogramming. And if you're not familiar with metaprogramming, it's simply code that writes code, which I really love about Ruby. But as a security person, absolutely cannot stand in terms of when user input is involved in that. So I'm going to show and explain what that means, but it really is a serious issue when we trust our users and we build code off of what they've given us. I mean, that sounds so common sense. That sounds so like duh, but it's not because we keep coming across it. So we're going to go over code, attack, and defense. The controller code you see in front of you. This is a classic example of metaprogramming. What we have here is this is a method designed to be super flexible. And basically a user gives us a parameter that is, represents a model, but it's just a string. And we call .classify and .constize on it, which makes it an object. And we call .find, and we look up some model object record with the identifier provided by the user, and that's params ID. And then once we have that record returned, we respond, respond with data.as JSON. So we feed back that JSON, basically that whole model record as JSON. So if it's not clear, let's start breaking it down. So just to give you a visual, this would be what your parameters look like when I said model and ID. We've got a schedules model here, and that's got a identifier. We're looking for a record of number 1. And you see that, so ID is 1. Now, how you can think of that is, the string schedules.classify, which all that does, and you can see it at the top, it just uppercases that string. So it's just schedule, uppercased. But when you call classify and constize together, what it does is it says schedule be an object. So this string schedule, let's see if there's an object named schedule that I can call. So in this case, right, we've got a schedule model that's returned, and you can see that in that second example there, because you can see schedule ID, integer, event type, string, data begins, date, so on and so forth. That's an actual model object that gets called or returned. And this is constantine is probably the most prevalent method we see this with. Well, I'll talk about some other methods we see as well. So this is basically what's going on. So we got this is the snippet of that code I showed you earlier. We've got a data object which represents the .classify.constantize.find. When you look at the SQL, all it's doing is saying select anything from the schedules table where the schedules ID is 1, and we get that that schedule object back there at the bottom under the Ruby model object. Cool. And then we return that data as JSON. So nothing out of the ordinary. Event description, event name, all that stuff. But the problem is when you don't restrict what models a user has access to. And that seems, again, pretty simple, but we see it all the time. So this is sort of what you would end up seeing. You'd see, permission levels are that of an admin, auth token, which is used as a remember me cookie, password with a poorly hashed password or a poor algorithm, all that stuff. And then this is the actual example that you'll see in RailsGoat, which is a little take on that. We'd seen this a while back and then put it in there. So the idea is that the parameter named type that the user gives us is going to be file. And when we call .new, we're passing in the name parameters. And then so we're trying to do basically a file.new and open a file with that. And then send the file. So now we're going to show the attack. So the way this manifests is we've got to go to benefit forms. And we're going to go ahead and intercept our request. We're going to download that file. So this is the raw request, this is the get request to download that file. But what we want to do is change it from file to logger. Because we want to actually use the logger class, because if you're not aware, logger allows you to pass in a string when you instantiate it. So if you do logger.new, you can pass in a string. And what we want to do is pass in a string with pipe. And when you do that, anything after the pipe symbol becomes a system command. So we want to create this slc.txt file. That's what we're going to create. And just to keep it so that the URL request is well formed, we have to URL encode any key characters. So before we do that, let's take a look in this directory. We don't have an slc.txt file. You can see that pretty clearly. We'll go ahead and forward this request off. Then if that worked, we hit ls. Yeah, you can see it now. So you can see there's an slc.txt and it doesn't exist there. So metaprogramming, when I talk about the other methods, you'll start to see where it's really dangerous. So you really can't trust the input that you're getting. So the most commonly misused methods are send action, constantize, the rest you see here. But the one that really stands out and honestly completely surprises me, I see it far too often, is eval. Don't use eval with user input. It's just a bad idea. If you're not familiar, eval basically takes a string and that entire string becomes code. So that's a really scary thing to use. Send action is used just to, you provided an action name, and if the controller has that action, it's going to send basically your request off to that action or that method within the controller. And send itself can be super dangerous depending on how you use it. Well, I should say it's dangerous with the exception that sometimes you get lucky and the impact's not as bad as you'd think. But most of the time, send, which, if you're not familiar, you call that send on a class or a module and or a receiver in general, and basically you're going to pass it a string, and that string's a method. So you're going to call a method on that object. as a string. So people do this with parameters. That's a really, really rough thing to do. So when we talk about prevention, Brakeman's great. Actually, Brakeman will find, in terms of the methods I just showed you, Brakeman will usually flag those. But why I say it's not a silver bullet is that, so for one, Brakeman's open source code, right? And it's code period, so it could change and miss something. I've not had that kind of experience with Brakeman, but you just have to be careful when you're developing so that you know, as long as you're careful and you're using Brakeman, you should be good. And also, when it gets to the metaprogramming, that's a little bit more difficult to. So it's not just a simple, hey, we called this method with this user input, and we're talking about levels of abstraction, and we're talking about, which method in the ancestor chain is actually getting executed, and all kinds of fun stuff like that. Obviously that takes a person to review that, and an automated tool can only go so far. So again, not a silver bullet. I can't guarantee it'll always be as easy as the examples I'm showing you. But if you want to use metaprogramming, again, I would say just don't do it with eval. But if you want to use metaprogramming and you want to use user input, then here's a simple way to do it. You create a list of acceptable parameters, essentially. In this case, acceptable models. You see it defined there at the bottom. You see schedules and retirements, just an array. And what we say is, if that list of acceptable models include the model that you're giving us, then we'll return that model classified, constantized, and found. Otherwise, just an empty hash, and we just provide that as JSON. So it's either going to be good or it isn't. We're going to force you to follow our rules, essentially. And for me, and everybody's different. For me, if I see user input going into a metaprogramming function, my default is no. You need to explain to me why that's necessary. How you do that in your own shop is up to you, but that's just my own personal rule. So I'm just going to drink a water real quick before moving on to our last topic. So injection. There are really two forms of injection that we see most. I mean, there's tons of SQL injection types. Injection types meaning LDAP, XML. There's lots of injection out there, but the ones that we see and that are very damaging are SQL injection and command injection. So besides having injection in their name, the real root issue of all of this is that whether it's the SQL server or whether it's the web server, a server cannot tell the difference between what is intended to be code and what is intended to be data, right? So, and we'll explain that when we talk about parameterized queries, but that's really all it boils down to. If you don't do things safely on your side and user inputs placed into a query or placed into a command, then obviously it can be altered by the user. And so there are ways to protect ourselves, which we'll cover, but that's the root deal here. That's what the issue is. That, and it's just a sort of a mindset of your application code being a little overly trusting. So we're going to go through, again, code, attack, and defense. So we're going to start with these normal parameters. There's a parameter key of taken sick days and a value of the number 2. And basically what we do here is we call paid time off .find, pass in all, so we want all records from paid time off that have a match to our condition. And our condition is if PTO taken is greater than or greater than or equal to, not less than, greater than or equal to the parameter you supplied us, which would be the number 2, we'll return those records to you. So you can see the raw SQL statement underneath there where it says select paid times off, or select anything from paid time off where PTO taken is greater than or equal to 2, and we've got our Ruby objects returned to us or database records returned to us. But what I want to show you here, I call it nefarious. All it really is showing you that we have more control over this SQL query than you'd expect, right? We're not doing anything super crazy here, but what you would expect and what we've put in here are two different things. Yeah, sure, we'll say where days taken are greater than or equal to 2, but we're also going to say and user ID equals 3. Which means if that works, we have way too much control over that SQL query. So what you can see here is we're gonna do the same query as before, paid time off, dot find all and conditions. And what you'll see is when the SQL executes with the quote unquote nefarious params, if you look after the where portion, you'll see PTO taken greater than or equal to and user ID equals 3, and that's a legitimately formed SQL statement. And I guess what you should take away visually from this is there's no single quote encapsulated around the 2 and user ID equals 3. That's not a value; it's a SQL statement. If that makes sense, and it will, I think. So in terms of the results, you'll see that there's only one result returned, and that's for the user with an ID of 3. So then we talk about parameterize, and I think that this is something that, when people do know about SQL injection, this is the one thing they're kind of familiar with. And the idea with parameterize is you'll see that we've got actually two separate pieces of data here. When we give conditions some information, we actually pass it an array. The first portion of that array is the SQL query, and anything after it is what's going to be replacing that question mark that you see, next to the right of PTO taken and greater than or equal to. So what really happens under the hood is a request goes off to the SQL server, and it says, here's the query that I'm going to give you, but I don't have the data yet. And then a second request is made with the actual data. And the SQL server is never confused, and it knows exactly what it's looking for. And it doesn't get confused on what type of query you actually want to run. And if you stuck more junk in there, it wouldn't get confused, and this is why. So when you actually look at it says normal params, this is a recap, if you will. Like the parameterized query does work. That's why I put this slide in here. Doesn't really change anything. You can see that we still have the taken sick days equals 2, SQL query executes, all that good stuff. And however, when we do the abnormal parameter or the SQL injection attempt that we had tried earlier, look at the SQL query this time. What happens is that 2 and user ID equals 3 is encapsulated as a string object, right? And that's all. It's going to look in the PTO taken column, and it's going to say, is there a string that matches exactly 2 and user ID equals 3? And of course there's not, because the results are 2, 3, 5, stuff like that. They're all integers, so you're not going to see any of that in there. And most importantly, it's just not SQL. It's not a SQL query that it doesn't get confused. And of course, at the bottom, you can see there's no result for that because there wouldn't be. But that's a pretty well-known one. But the ones that aren't, and I have there's a site I'm going to give you at the end of this that has a huge list of methods that you may be surprised by. May not really have understood that they were as vulnerable as they are. So my favorite to demonstrate is pluck. Pluck's a very straightforward method to kind of show or showcase how a method you think might be safe isn't. So basically, Pluck's job is to take a value and return you all the results. So take that value and say, hey, I want all the results from the column that matches the value that I was given, right? So if I give it PTO taken, it wants all the results from the PTO taken column for that table. So in our example, we use paid time off again, and we say, hey, I'm going to pass you this params field, which is the PTO taken value. And so what's happening is it says select PTO taken from paid time offs, and there's the result: 5, 3, 5, 10. Cool, as it should be. But it gets a little weird because how this query works is it takes our input and puts it into a select statement. And it puts it in a way that's unsafe. So When we do SSN from work infos -- what we're saying is select SSN from work infos, comment out the rest. I don't want to do the from paid time offs portion of this request. I don't. And so what you'll see is when we do paid time off, the paid time off table, and when you call pluck, we're still able to return from a different table, from the work infos table, the social security numbers that are stored. So there's our result, fake social security numbers. And how do we fix this? In this particular case, if we needed the users to provide us a column, we'd go back to sort of that, hey, I'm going to create an array, or I'm going to create a list of acceptable parameters acceptable parameter values. And if that parameter value matches up with what's acceptable, then cool, we're good. Otherwise, no, I'm not going to do anything with it. So we're going to talk both on. So when we get to the end, we're going to talk about SQL injection and command injection, a little bit more in depth prevention, but I'm going to save that since they sort of have an overlap. Moving right into command injection. Basically, this is still, again, confusion with data encode. Just a different server. And because this is being executed by the code that's running as your web server user, that's the level of permissions you have. However, you can actually do a lot of cool stuff, a lot of fun stuff with that. Basically, you can still own the server, but we'll get to that. So what we're going to do here is take a parameter with a key value of directory and a key name of directory and a value of public. And we got some code here that makes a system call, ls params directory. And so what we're really doing here is an ls on the public directory. And all that stuff that's in there is pretty much what we'd expect. But what happens when we append a semicolon and another command? Well, the way that code was set up, when you look at it, it was using the insecure form of system. And I'll show you the secure version. And so what that means is anything that gets passed in just takes that string and just makes a system call with it. So really it's ls public semicolon, meaning in Unix land, hey, I got another command coming at you. We're going to copy that secret token over to the public directory. And if you're not familiar, if you have access to the secret token and you're dealing with an application that uses client-side cookies and they're not encrypted, that leads to remote code execution. There's actually, if you've heard of Metasploit, you know that it's got a module that you can just paste in that secret token, and you can give it a host to run this exploit at, and it'll get you access to that box. So the public directory, for those that aren't familiar, with Rails specifically, anything that goes into that public folder is in the public. I mean, it's you can anonymously browse to it. It's accessible to everybody. It's accessible to the public. It's aptly named. And, just to show you that it did work, that is the result. We do see a secret token file put into the public directory. So this is the way to fix it, though. If you ever need to use a system call, which I'll reiterate it later, but I really don't, there's most times not a good reason for it, but there has been one instance where I've seen it where it was, I got it. I kind of understood why they had to do it that way. Only one. Anyway, so when you take each particular command, string encapsulated, that's why you see ls is its own string, it's comma separated, and then you've got the second string or command, it becomes parameterized, right? So what you see underneath that highlighted code is ls public, blah, 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 no such file or directory. And why is that? Because ls is trying to run an ls on that entire, it thinks public, everywhere from public to secret token and that public / it thinks all of that is one string and is trying to do an ls on that directory. And of course, that directory doesn't exist. So this is one way to mitigate that problem. I've looked into it. I've tried bypassing a little bit. I've not found a good way to exploit this method. So I would say, as of right now, if you have to do it, absolutely have to do it, really evaluate it, while you're doing that, you should use this instead. And then you can see that when we use the parameterized version, as you'd expect, there is no secret token placed into the public folder. So these are the, and Brakeman does find some of these things. So with system, the non-parameterized version backticks an exec, as well as eval, because obviously eval, if it takes a string and you can do anything, like whatever that string is becomes code. Obviously you can run, you could run a system command from using eval. Those are the four ways that I see this come across, and all these guys see this come across and manifest in Rails applications. So at the root of all this is don't trust users. I mean, honestly, we can go through, all the training. We do some pretty advanced stuff. We could go through all that, but at the end of the day, so much of this boils down to just don't trust input, don't trust users. Just don't do it. If you concatenate or interpolate user input into something that's important without doing some kind of sanity check, it's gonna end up badly. So just don't trust them. Have that in your mindset, and you're gonna be cool. And then in terms of things to do, I highly recommend, and I'm going to leave this slide up for 30 seconds. This railssqli.org link that I put in here, use it, go to it. At the very bottom of this page there, you can see a link to download the code. And basically you can spin the server up locally. You can run through all the exercises. That Rails SQLi site has a list of the exercises and all the vulnerabilities and how they manifest. It's a really good read. It's a really important one, and you should definitely be exercising, your SQL injection foo, because if you can think like an attacker, you can most certainly defend against one. Again, whitelisting, that's okay. That's really good. Active record is mostly good, except for, like I said, when you go there to that site, you'll see what I was talking about. And just avoid system calls if you can do it. But if you absolutely have to, use the parameterized version of the system call. Okay, so that was the high level for those three categories of vulnerabilities. We're a few minutes early. Are there any questions? Mike, we all clear?
Yeah, there are no questions right now.
Okay, all right. I had baked in a lot of time for questions because I go, don't feel like some people are, believe this is, hey, too advanced for this stuff, and that's fine. If you want the advanced stuff, come talk to us. For those who think the opposite of that, where it's like a little too much to they're inundated a little bit, that's why I'm baking in this time right now. And you can, ask your question anonymously, and I'll go ahead and answer that, and it'll be fine.
So we have, is there ever an instance where eval is good to use? It seems like it's always a red flag in code, so why use it at all?
You're just echoing base. It's a good question. I have that same question myself. The reasons we see people use that, though, and it's the same with system. So typically, it's either a shortcut, right? Like it was easy. They could reuse some, and that's, dry is great, but you can definitely shoot yourself in the foot with that. Don't repeat yourself mantra. The other is that sometimes command line tools have to be used. And in those instances, for some reason, eval is the default too, or other insecure methods. And like I said, just evaluate if you really need it and parameterize it if you can using the parameterized version. Anything else?
None so far.
All right, cool. Well, I appreciate everybody, attending today. We're going to continue going deeper into different topics, as well as, we'll revisit Rails, and we'll probably do some advanced stuff as well. So again, greatly appreciate it. There is a survey at the very end of this, though. I really ask that you fill out the survey because it's how we curate content. It's really us trying to figure out what you'd like to see, how you'd like to see it. It's just super important to us. So if you can fill out that survey at the end of this, again, greatly appreciate it. Thanks everyone. Thank you for coming out. Appreciate it.